guys, this is Math 112 and we're going to start our exponential unit. I'm going to try to keep these videos to about 9 minutes or less, and we'll just stop and pick up at the next video just so that you have time to watch it if you need to, or move on to the next one. I don't want you to be too bogged down. So let's go through and start talking about these exponential functions. An exponential function is a function where the variable is an exponent. And that's what's really different about this one. Notice that the variable is in the exponent, and that's what makes it an exponential function. It has a base b, this thing's called a base, and the base is a number. And specific things about it, it has to be greater than 0, it can't be a negative number, and it can't be 1. And we'll think about that for some time and maybe it'll make sense to you. But for right now, it's a number raised to a power, and the variable is actually in the exponent. The domain is any number. You can put any number in an exponent. The range is 0 to infinity. Now, if you got the document, this is all on that document that I sent out in the email earlier. And so the PowerPoints are come directly off that document, so you can look at that. The graph always looks like this. This is just some variation, just some generic graph. It never touches the x-axis, and that means that you have a y = 0 horizontal asymptote. We talked about asymptotes when we did rationals, and so there we go. Now, the documents that I sent out, the first one was your power sheet, and the second one was all your exponent rules. Those two things are going to be very handy in working with exponents. So just remember your exponent rules. You may not remember them. So we're just going to graph one. We're going to do 2 to the x. We're going to graph this real quickly. And so we have 2 to the -2, 2 to the -1, 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, and 2 to the 4, because we can plug in any number into our variable, and our variable is an x. And so the problem comes with people forgetting what these are, and that's where you have your exponent rules. 2 to the 4th is 16, and 2 to the 3rd is 8, and 2 to the 2nd is 4. So those aren't too difficult. 2 to the 1st is 2. But then we do the 0 and the negatives, we forget what those are. 2 to the 0 power is 1. As a matter of fact, anything to the 0 power is going to be 1. And that's going to be hard for some people to understand. Negative exponents are reciprocals. This is going to be 1 over 2 to the 1st, or just 1/2. And this one is 1 over 2 to the 2nd, which is 1/4. And so those are our points. And I'm going to just do a real small sketch so you can kind of see how this shape comes about. When x is -2, we have positive 1/4, which is just barely above that, barely above the x-axis. And then when x is -1, we are at 1/2. Let's try again. My stylus is not what it used to be. I'm going to have to think about getting another one. And then when x is 0, we have 1. Now, this, notice, is a point on the just generic graph, because anything to the 0 power is 1, so it really doesn't matter what b is. That point's usually in there. And then we have the point 1, 2, and then the point 2, 4, and then 3, 8, which would actually be there, and 4, 16, 2, 4, whoops, lost count, 2, 4, 6, 8, 10, 12, 14, 16. And so we have this graph, this asymptote. I don't like that. Let's try again. goes up and up and up and up. Now, we talked about this is an exponential growth graph, and it just keeps going without bound. That is just your basic exponential function with domain and range. All right. The next thing we want to do is learn how to solve exponential equations. And so these, you really need your exponent sheet. You need to know your exponent rules. I gave you a sheet. Check on it. If you want to print it out, that's one of those handouts at the beginning. I sent you a document. The first page had all the power numbers, and the second page had all the rules. So just basic exponential equations. We're going to make the bases alike, and then we'll just solve. So for example, we have 4. Well, 4 is a power of 2, so just make this little substitution here. 4 is a power of 2. So I just make that little substitution. And then if you remember your exponent rules, these multiply, so that turns into 2x. And so then I have 2x equal 1. Because once the bases are the same, like that. Hold on. Once the bases are the same, it's just an easy solve. And I have 2x equals 1, divide both sides by 2, and then x is 1/2. So let's check this next one. This next one, 125 is 5 to the third. Now I have that memorized, but it is on that sheet. And so 125 is 5 to the third, and then that's raised to the x power, and then 5. So all I did was make that substitution from here to here. And so then this is going to be 5 to the 3x is equal to 5 to the 1. Well, that just brings up this little baby equation, 3x equal 1. Now, not all the problems work that way. X is equal to 1/3. But these are the basic ones. The basic ones do that. All right, I'll finish this next one, then I've got something else we want to do. Okay, so this one, this is 3/4 to the second. Now, again, you have to look at your sheet to figure that out. You have to get things alike. You have to try to make your bases alike. You have to do it. You have to look at your sheet. You have to think. It doesn't just come to you. You have to make your bases alike. And then this next one, they're not alike. They're flipped. Sorry, that's a goof right there. They're flipped. So we need to flip one of them. And there's an exponent rule that says if you make it negative, it flips. Again, exponent rules. You're like, holy moly, I don't remember any of them. I understand. So now again, we have a baby equation, and our baby equation basically is our answer. Oop, can't see that. But our answer is x equal -2. So that is the simplest equations that you need to look at with exponentials. So we did the graphing and then basic equations. All right, we're going to stop the video, and we'll pick up some other problems on the next video.